but it's a 12-foot ceiling. So Ben is going to be my fishing line. So what I do is literally I suspend it about this high, maybe a little bit lower. And then what you do is you go to Hobby Lobby and you buy a piece of foam core or what's called foam board, right, for about $5. So for less than $20, and how do you cut out an ellipse? You guys know how to do this, right? Is we have a piece of string, right? And we find 2 points, and we call those the foci, which is plural of focus, right? And then I take a pencil and I go around and I make sure the string is tight. And the further apart these foci are, the more the eccentricity, right? Now you don't want to do something that looks like a circular orbit. You want to do something that's more eccentric. And if I were to do this over again, I would even separate these out further. The problem is, this is the largest foam board that I could buy at home at Hobby Lobby, right, for $5 or $6. Okay, so what you see what I did is I created a vertical line that said focus. I created another vertical line that said focus. I created semi-major axis, right? So now you can throw this out. I just brought this so you know how to do an ellipse, right? You guys all know how to do that. All right, this is the visual aid, right? So what Keplerian elements do we already have without even using the globe? We have the semi-major axis, we have the eccentricity, so now we have the size and we have the shape of the orbit. Now we have to orient it around the globe, right? So like Ben said, I don't know if we can do this with Ben here. All right, so, we didn't tell you, the first Keplerian law is that the orbit occurs with the Earth at one of the foci, right? So what I'm going to do is I'm going to locate the focus, one focus, right through the center of the Earth, right? So this is an equatorial orbit, right? And, oh my God, we can't get a polar orbit out of this, can we? This would be a polar orbit, 90 degrees, right? And of course, the space station is, I think, 50-some degrees or something like that.
47.8.
Yeah. So 45 degrees, this would be an inclination. So the kids can visualize that, right? Okay, now, here's the hard part. The right ascension of the ascending node, remember I told you it's a red vector in space. Let's say that it's that way. Spring equinox, right through the equator, right through the sun, it's a red vector. So where Ben is standing, that vector goes right through him, right? Okay, so if I do that, where is my ascending node? It's over here, right? Ascending node is from southern hemisphere to northern hemisphere, right at the equator. So what would the right ascension of the ascending node be? Omega would be how many degrees?
180.
180, because there is the vernal equinox vector, and we go 180. So here's my ascending node, right? Now what I could do is I could make my ascending node, I'm at inclination of 45 degrees, I could make my ascending node 90 degrees, right? I could make my ascending node 0 degrees, but then you would be looking at the underside of this, right? So let's keep the ascending node at 180 degrees. Everybody got that? 180 degrees. So what's left? Perigee, which is right here. Apogee, which is right here. So the argument of the perigee is the hula hoop thing, right? We're going to slide it around, right? So if I do this, then what is the argument of the perigee? It's going to be 180 from the right ascension of the ascending node, because we reference the argument of the perigee from the ascending node, right? So it would be 180. If I go back over here, I still have right ascension of the ascending node, 180. My argument of my perigee is going to be 90 from the ascending node. And then, of course, we have to locate the satellite, and that's going to be the true anomaly, right? In any particular point in time. Does this help?
And that measures from back here.
And it measures from the perigee, right? Perigee is 0 degrees for true anomaly. And then we measure an angle from the perigee. So you can even have your students come up and demo. You know, if they think they understand it, they can come up and they can do a demo. It's a lot easier rather than Ben holding it,
It's hanging from the ceiling.
hanging from the ceiling.
If they